Okay, so this is just a test stream. We have set up a complete streaming setup at NimbleBox office, and what we're going to do is, this is just me trying out like if this works or not. I'm most likely going to put this on my personal YouTube channel, but yeah, let's see. I mean, honestly, the only way to find out if this works well or not is to do like at least a stream for at least 30 minutes ish. Sun is about to set and day is about to get better at NimbleBox at Chennai. Alright, so what are we doing? Right now, this is part of a tutorial that we're making at NimbleBox for on how you can like deploy, like fine tune and deploy stable diffusion model on NimbleBox platform. There'll be like a full-on video on what we do at NimbleBox, how it all works and everything some other day. But for now, we'll just start quickly. So what I have is an instance running. It's a pretty basic instance, a 4-core, 15 GB RAM, a T4 GPU. It's going to shut down in 46 minutes by itself. And so yeah, let's see. Alright, what are we doing here? So we have this script called train dream booth, and we're basically creating, I'm just basically creating this kind of a GitHub repo where like there's a bunch of different ways on how you can fine tune different stable diffusion models. I already have one running, so what I'm actually just going to do is I'm refactoring the code a little bit here and there to make it into a single script, and then I'll try to complete the, or at least try to run the text to image LoRa using the LoRa algorithm. So yeah, let's start. Alright, this is the file that needs to be made into like a single unified big thing. What I have here is like a script that initially used to call functions from this file, but now it's all a single file. So I'm just copy pasting a bunch of items from the right panel to the left panel. What this is going to do is it's going to train the model, run the training loop, and create checkpoint files. Then we will essentially upload those checkpoint files to the artifacts on NBX, which is NimbleBox. In fact, we don't actually need to do this since this thing already takes in a project. All the checkpointing can be done automatically. So what I'm just going to do is I'm going to go here. Here we define the tracker, and this is the main loop. What I need to find out is where does it actually store the checkpoint files. Okay, it looks like it's doing something here. Python 3 / content blah 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 blah. It's going to save it at this particular path. Checkpoint name changes. Okay, perfect. So what I can do is I can just run something like tracker dot save file, and I can just give it the basically the save directory, and this will automatically save all the files inside the save directory recursively and all that shit. So I can go inside save files. You can see it takes in a file, folder file. If it's a directory, then it's going to find out all the files that are present in this thing. It's going to take all the files and it's just going to put them at this particular location in the relic, which is like the code name for artifact. Okay. Yeah, we should never forget like to enter logging for the tracker, otherwise like people can corrupt the dataset in their own. Yeah, it's easy to mess up like that. So I don't think I need this because we anyways are going to save them. What in fact we are also going to do is we are automatically, if there are logs, then we need to avoid it. So I guess we can also put this somewhere here. I'm going to put a comment here which is like to do at the Monday complete the complete this part of the code. Currently this thing will break, so another thing that I have to definitely check for is if tracker is not none, and we then in that case do this. Perfect. This is not the best one, but this is what we have right now. And another piece that we need is the manifest file. So since this thing anyways takes in the arguments from this particular place, and then we also go ahead and like merge these two arguments, so that's a little bit of a weird thing. This is just some super old code. We haven't updated it in a while. So I have this, but I do need the manifest right here, which means if I pass it, the args are going to be parsed right here. Okay, so I'm going to just do this, and I'm just going to pass the args right here, args default, and then I'm just going to do args default dot manifest, and manifest 5p is equal to this thing. I can do this, and then I can do this, and then I can do this. Load images will essentially, okay, there is no load images. I need to import from common import load images. Perfect. Just as a double validation, I'll go here and boom, this thing opens up. Okay, perfect. Close this thing. Now what I'm working on is a browser based IDE, and not just like VS Code. You can have anything that you really want to run and expose on a port. It can be run via the NimbleBox platform. Any instance, essentially a VM, you can like define anything that you want. I haven't done any of that. These things work well enough for me, so I haven't done anything, but yeah, you can go here, click on Jupyter, MLflow, whatever you really need, you can just pick them from here. Okay, I'll also just double check. Now this thing is ideally going to OOP, which is fine. So let's just run this thing once just to validate if everything works or not. Oh wait, we haven't added the manifest as a part of this thing. So I can go here, -- manifest, and required is true. And then is no need for default path to the training manifest file. I'll also quickly show you what the manifest file looks like. It's a pretty generic file. Essentially a manifest file is like what we want to fine tune on. You can make it as complex as you want. This can be like a JSON-L and whatnot. Right now this is a JSON. Now here I have like provided a bunch of images that I want to train on. So here's the path and the prompt. I'll also show you like a couple of simple examples. Now these are from a friend of mine, so I'm not sure if I should show them, but I'll show you a particular one that I really love. So his name is Bala. He has his own, just a unique and amazing style of drawing things. And what I wanted was like, what is it possible that I can generate more images in his peculiar and very interesting style. So this is like one kind of an image, which is heart and hand.jpg. And in the manifest you can see I've given a prompt which is like a beautiful purple hand holding red heart with planets in the background and black universe and stars. With planets and stars and black universe in the background. Another interesting thing that is implemented on the NimbleBox build is like I can actually mount any kind of S3 directly onto this instance. So for example, right now I'm changing this manifest file which is inside this repository. Yeah, you can see I have this manifest file here. I have changed this thing, but it doesn't appear here. But the interesting thing is, if I just go inside the manifest on the S3 bucket and I change the files right here and save it, it is automatically going to sync it onto the cloud as well. Just to double check, I can go here, I can click on artifacts. This is just going to show me like all the files that are present in my S3, and it should ideally, you know, be pretty printed, but whatever. Yeah, so you can see like it did update directly you can update the object on the S3 as if it is on your local machine, which I find pretty cool. Okay, so now let us run this thing. I'll just do python 3 src. Oh wait, I changed the name of the file. This file is now called train dream booth. Now you can see there is NVIDIA already available on the instance. So if you start with any specific instance that has GPU and everything set up, this thing will automatically work. The NVIDIA SMI, everything is already present. You can see it has started doing something. It has started to load a couple of things into the memory now. Yeah, you can see now the TensorFlow is being imported. Now we won't actually run it on the TensorFlow, but well, I mean, it's already available, so it's going to try. Perfect. It threw the error as expected that hey, the manifest file is not present. I'm going to let it exit gracefully, and then I'm going to do manifest, and I'll just pass it the manifest.json file on my local machine. Now the reason we have also we have these duplicate copies, one on S3 and one on the local machine, is so that when you're actually training it on top of the platform as a job, it's already available and it's like already synced and everything. It's really easy to like screw up on your local machine and like expect the same thing to happen, but it's not going to happen. Perfect. It has loaded all the images. Now the images are automatically synced. I just created like a symlink right here. You can see it has created the logs and whatnot. It also has the TensorFlow output, which is these are like the tensor board outputs. Makes sense. These are the instance images on which it is going to train. We don't really change any of these pieces. A lot of these pieces were already present in the code that we're using, so we didn't like touch it a lot. Okay, it says snapshot download is not defined, which is fine. Still in the process of merging all these different things. I can go here from Hugging Face Hub. Okay. Now you can SSH into this instance, use tmarks, and do all kinds of wild things that you want. I prefer running it on a browser. I have no interest on running it locally. You can see I have it available locally, and if I want to connect it the remote instance, I can just connect it, give it like the SSH command and whatnot, and it would work. But anyways, I'm not interested in that. Manifest is not defined. Do you mean manifest FP? Yes, I do mean a manifest FP. Line 989. I can scroll down to 98. Yeah, perfect. So I mean, it did come till this particular place, right? So it would have printed the arguments. Yeah, here they are. Let me also do one thing. Might not like insanely hard to read what are the default like the arguments that are going to be used, and I am also like a little bit obsessed with like correct like beautiful code never hurt anyone. In fact, it only helps. So let me just change things a little bit here and there. I'm not going to change this part because I believe if I change this part there might be some other kinds of issues that might happen. I'm pretty sure they won't, but why, you know, bother? If something works, let it be. That's like the default of software development, isn't it? NimbleBox is our SDK, or CLI or APIs or whatever you really want to call it. It's a Python package for NimbleBox. Okay, perfect. So this is here. Now what I wanted to do is I want to pretty print these things. So what I'll do is from preprint import pformat, go down here and I'll just do pformat vars args. Yeah, this thing should work. Vars will automatically convert it to a dictionary, and pformat will also automatically pretty print it on the terminal. So we'll just wait while this thing works. Okay. So right now everybody is in the process of yeah, you can see much more readable. In a short while it should also start loading up the models. You can see it has started loading up with things in the RAM, and then the files will be copied over from the RAM to the storage on the chip on the GPU. Interesting. It turns out like this VS Code, the code server takes a lot of CPU but not a lot of RAM, so we'll just sort it by memory. This in one very clean swoop will tell us hey, your training is really taking most of the memory. Yeah, perfect. It started loading it in the memory on GPU. Yeah, this thing will crash in a bit because of OOM, which is why we have another script which is train text to image using LORA. Perfect. Let me bring this tab from my other screen to this place. It is here. So in this stream we are already 18 minutes in. I really don't want to spend a lot of time on this thing. This is again just a very test streaming kind of a thing, just to see if I still have it. I think I still have it. I don't know, maybe. Okay, you can see it has said that it's initializing the NBX tracker, which is a equivalent to weights and biases. So you can log all the artifacts, log all the metrics, any arbitrary metrics that you really want to log can be stored here, and boom, it's going to die. Perfect. Yeah, you can see it killed the process. We should see some kind of an OOM here. Yeah, you have the cooled out of memory, which means oh fuck, it's my screen is coming, face is coming here. So you can see it ran out of the CUDA memory, which is fine. It is expected. If you want, you can spin it up using a much larger machine, with a much more GPU and whatnot, and it should work. That should be fine. It's not available in the selected region, which is also it's okay. Essentially on build we are not going to be training these models. The objective really of build is to test out if the code works correctly or not. Right now what we have tested and seen is hey, the code works correctly. The actual training will happen using NimbleBox jobs. where you can schedule any kind of arbitrary batch workload, specifically especially training of models and whatnot, and we will use those, and there you can get like much bigger resources, you can get dedicated hardware and all kinds of things. Perfect. So this thing works. What I'm also going to do is I'm just going to delete this train text to image. I can go here, I can permanently delete, yes, delete train dream booth, and in the meanwhile I'll also just create a new commit. I think I should like cite this thing where I got this script from. Again, never really hurts to have correct citations. Perfect. Get add dot, get status, get commit dash m, add rewrite or refactor dream booth training to a single file, and then we can do get push. Perfect. Now I understand like the screen is like a little bit too the font is a little bit too tiny for a lot of people, but honestly it's okay, just get a bigger screen. That's a simpler solution. I have a 4K screen, and anyways I'm recording it in like 1080p. It looks beautiful in front of me, but it's going to look a little bit shitty on the on YouTube. Now let's look at this particular file. I honestly haven't looked at this thing. I don't even know what is LoRa. Oh wow, we're using proprietary radio communication technique to train neural networks. We've come really far ahead, huh? Low rank, no LoRa, not loans, low rank adaptation. So this is for diffusers. It says low rank adaptation of large language models, but this is inside diffusers, so I'm not really sure if it should be here, but whatever. Yeah, so they are fine tuning stable diffusion v1.5 on the Pokemon dataset. What really is this dataset? Let's take a look at it. A drawing of a green Pokemon with big red eyes. Wow. Isn't that Bulbasaur? Yep. And is it possible to do reverse search? A Pokemon with okay, nope. What if, okay, go here. Can we do like an image search? Why are you uploading, bro? You literally are Google, you know exactly what I'm dragging. Electrode. Interesting. Alright, so I think I went to this page, I'm not really sure. And I got the training script from here, which will essentially take me to this particular page. What I did next was I picked up the LORA thingy. I copy pasted and created and made a new script from it. Let me just close all of this. And all we are going to do is we are going to bring it in sync with our previous code. So I can go to Dream Booth, I can just go here, I'll copy the manifest details. So if I try to run this particular file, this should fail. Again, who really writes it in this kind of like an insane order, man? Come on, like, you know, my personal opinion is machine learning engineers really suck at writing great software. And it's no reason of their own, it's just, it is what it is. Okay, now we're going to try running this particular, oh fuck no, okay, perfect. Control C, we'll just try running this particular code, Python 3.py. Now again it should, no module name, datasets. We don't really need datasets, so for now I'll just comment this thing. What I just want to check is like it should throw the error that hey, manifest object is not found. What is the requirements for these guys is accelerate greater than 0, 16, 0. So we'll just do the same thing. Pip 3. Wait, what? Into some place I can't describe. Okay, this thing works. Now we will try running this file again. No module name datasets, bro. Where is this coming from? Line number 38. Bro, why are you like importing it twice, bro? Like what the hell? How stupid is that? Okay, perfect. It did cry like, hey, I need the manifest in the pre-training model name. We'll go to this blog and we will change, like copy a bunch of things from here. So the model name is going to be stable diff 1.5. Not the best one out there. We already have two, but it's okay. And for manifest, I can just do manifest.json. I can't describe. Need a dataset name or training folder. Okay, cool. Okay, perfect. So I think I don't think we need any of this. Perfect. Okay. Anyways, check it. So this stream is just to test like if everything works correctly or not. I am going to upload this on my local machine, my personal YouTube, and then see how it looks like, how it feels like. Is the audio crisp and clear? Because I don't want to screw up on the official streams from when we do those. We have set up, we have done a very nice setup. There's like a tree and everything behind me, and there's like a camera, but it's actually discharged right now, so I have to use the built-in camera for the Mac. Well, perfect. Well, I guess I'll see you guys later. Bye bye.